Mathematical Physics Acceleration. We have several topics going on in this unit. We'll start with instantaneous velocity, then define acceleration, and once again we'll have graphs. We'll have velocity time graphs with acceleration. Then we'll say how you can find the displacement from the velocity time graph. Not only can you find acceleration, you can find displacement. That's pretty cool. Then we'll summarize it, have some mixed problems, and then a special chapter on free fall, which is the acceleration due to gravity. Instantaneous velocity. Hopefully you recall the pullback car lab from the constant speed motion unit. Check your lab notes if you need to be refreshed. What was the car's motion when you released it? Did its speed change from start to finish? If so, how did it change? Write down, either on the screen or on a piece of paper, a summary of your observations relating to the questions that were asked on the previous slide, and anything else you noticed about the car, how it was moving. Hopefully you observed that the car started from rest, v is equal to 0, the car's speed increased, and it might have changed direction. Eventually it slowed down and then came to a stop, so where you have v equals 0 again. The car did not move with constant velocity because it started out pretty fast and then it slowed down until it finally stopped. When you determined the car's velocity in the last unit, it was the average velocity. The car's velocity, speed, and direction you observed at each moment was the instantaneous velocity. So two things. Average velocity is over a period of time. Instantaneous velocity is right at that split second that you saw it moving. When we introduced position in the last unit, we talked about how a race wouldn't be as interesting if all we wanted to know was how far somebody went, the distance traveled, and how long it took. In other words, we were only interested in the average speed or velocity, not very interested. What makes a race interesting is knowing where and how fast the runners are going at each moment of time. That's the instantaneous velocity. So we can see the runners, so if there was one runner here, and then another one is coming up behind the runner, and how fast they're closing the distance between them, where they are in the track. Do they only have 10 yards until the end? Do they have 100 yards? Do they have 20 meters? Do they have 5 meters? That's interesting. We can observe instantaneous velocity in many different ways. We can see it changing speed or direction by eye, a measurement, or with an instrument. So here's the speedometer on a car. This will show us the changing speed. This over here is a compass. Depending on which way we point it or which way we're walking, that will show a different direction. And right over here, this is a speed monitoring device from a policeman. And actually that's a cardboard cutout of a policeman. It's designed for people to see. And here's the camera over here that tells them how fast you're going, or tells whoever's connected to the camera. Of course, he's just a cardboard figure.